Next is Sebastien Fabbro, who is going to talk about Gentoo at home. The title is not very descriptive, so let's see what he has to say.
Here? Okay. So hi everyone, I am Sebastien, also known as Bicatali. I work in Gentoo, I volunteer in Gentoo as a developer for the scientific project. And right now I'm going to present something which is not too much deal with science, although you'll see later that it had some links in the roots. And this is an idea that we have too many automation tests in Gentoo that we cannot really do something only by ourselves. So we need the community to help us to propagate all the automations. So that's why I say Gentoo at home, to the reference to some other project using volunteer computing called SETI at home. I don't know if you know that, the search for extraterrestrial intelligence using different computers all over the world. The idea is, so in Gentoo we have this package workflow. So when a developer has a new package that you create and you update, then you commit it, it's been tested either by QA or by users, and then we fix it. The developers keep fixing, and then there's back and forth between the fix and the test. Then once there is a sort of stabilization for 30 days, the developer waits for 30 days, then we file stabilization request. And then a bunch of our architecture testers test the package the way it should be, or most of the time they don't know how to test it, and then the developers are fairly lazy to send over how to test it and everything. So there's then the package is tested, it's committed, then other bugs are found by the users, so there's again a back and forth to fix it, and then at the end maybe we have happy users. This is fine. I mean, this is a pretty decent workflow. It's been working for the last 10 years, or 12 years now for Gentoo, so there's nothing wrong with that. The problem is that sometimes we have too many combinations. So like you give a package, you want to test it properly, then you do for each different configuration of a package, because we're a source-based distro, you want to install the dependencies of the package. You want to install the package, and then you want to, and you're running the unit test of the package, test the package as an integration test, like how does it fit with all the other packages that depend on it. And then you want to remove properly the package and the dependencies, and you want to do it for every single combination of use flag, compilers, and everything. So in the tree, just to give you a few ideas of the statistics, we have like 16,000 packages. Only for the main tree, I'm talking about the main Gentoo tree. So it makes it 32,000 approximately ebuilds. So if we have 5,000 use flags, and an average of 2 per ebuild, and then if we want to really test everything, we could say, okay, we have X version of GCC, we now have clang, and some people want to use ICC, the Intel compiler, so up to 12 different C++ compilers, which covers about 10,000 packages. Then we have another 10 different Python implementation with pypy and with Python 3 and Jython. And then we have Ruby and then Java. So too many different combinations of everything. At the end, if you want really to test every single combination, you end up with like maybe 100 million tests. So obviously it doesn't, it's not really human. So you want to automate it. How do you automate that? it's ambitious, so you not only you wanted it for the keywording, which means that from a package that works on you want to make sure that a given package works on a given architecture, then you want to go for the stabilization automation, sorry. And then the QA, you could think that everything could be automated using to build our binary package, our binary packages, which other distros do. Then doing benchmarks, next there will be a talk by Andrea about it. And then also testing different configuration, integration test, maybe release. So other distros, actually right now there's a talk next door about OpenQA. I'm not familiar with any of these things, so don't ask me about that. There's Fedora AutoQA. I've just Googled a few things, and then Ubuntu has quite a few things to automate that. The problems with that is obviously they're binaries distros, so they don't cover all the things we want to do with Gentoo. I don't think we can do everything, obviously, but we can probably select a different set of good default things that we could use for. So what's the solution? Well, the idea was to use the community resources. So that's why you want to use volunteer computing. So volunteer computing, so I mentioned is there's quite a few things used mainly for science right now. SETI at home, you have Einstein at home trying to search for gravitational waves from pulsars as well. Then you have a bunch of things in physics using the theory from the quantum chromodynamics and other things from from the LHC basically. So for this, since we are distro, we want to start from a really clean base system. So the idea is to virtualize it and make a really minimal base system. So why do you want to virtualize it? Because first you have really clean system that you always start from scratch, and then you can also combine. You can send all your jobs to the Microsoft Windows user. So it's pretty nice. They're still the most common users. Well, if we want to run it on Gentoo, we could use much less resource-hungry virtualization things like Linux containers, and this hasn't been tested yet. So I haven't done it with users, so it's a bit of a really test project right now. So if you're interested, let me know. I happen to work I'm a scientist, so I happen to work in a big data center for astronomy, and then over there we have we're trying to base cloud computing things for astronomers, and then we build 2 different clusters in 2 different locations, and we're trying to schedule all the jobs to the clusters, which use different Linux distribution, different setups, and everything. So we're trying to we're using virtual machine to send all the jobs to the clusters. So the clusters are built with Nimbus. Well, it's for whoever is interested in it. It's built with Nimbus, and we use a scheduler between using all the jobs using Condor, which is a batch scheduler, big program. And we also use a thing that is homemade by our team. It's called the cloud scheduler to schedule the virtual images between all the different clouds on a transparent way. This is, all those things are actually open source, so you can Google for them. The test I've done, I took a minimal Gentoo virtual machine with their Xen kernel because I had to. Right now, the clusters they use only Xen kernel. So don't tell I've used this to do my test, because supposedly I'm doing only science on my on the clusters. And so at first it didn't work so much, so I had to switch to Scientific Linux 5, which was completely compatible with the clusters. Scientific Linux 5 is just a clone of Red Hat 5. rebuild from source, adding a few more things, and then I use a minimal prefix Gentoo on top of that. Just to tell you how the things are big, it can be quite big. I installed just this package called root, which is a high energy physics really end-up package, which has a huge load of lots of dependencies. We have 27 use flags. So if you want to really test every use flag, you up to 2 to the 27 combinations. Obviously, some combinations are not possible, so it's not completely these numbers. On a four core machines, it usually takes 15 minutes. So I just do some quick tests, the unit test, and then some integration tests. There's a benchmark suite associated with root. And so I got a bunch of failures and some successes. I had to, it's a little bit tricky because you have to install the binary system first, remove them, install them again. So the jobs can be pretty long. So to switch to voluntary computing, we need to do other things. I mean, obviously we cannot use scientific resources for building Gentoo packages. So the idea is to use BOINC, which is a volunteer computing framework to use computers at home. We could maybe use Condor. Condor is the ones I've mentioned before to schedule jobs. I'm not really sure about that, so I'm open to suggestions. But I think BOINC works so well for so many different science projects that it probably is the easiest to do. We'll have to do it on the server side too, though. So how to do it, really? We could download a given stage of Gentoo each time. So maybe we have to regenerate the VM every day because the Gentoo tree is really moving, especially if you do it on an unstable system. So one thing we could do is use what those guys at LHC at home do is use a network read-only file system called cvnts, which works. It's a fuse-based system, so as much as people like fuse, but it's still quite powerful. CERN uses to dispatch jobs about to 100,000 users, so I think it's fairly quite robust. So we could put the tree on the server side, and then the users just mount the tree on the network. It's an on-demand file. There's a cache system that makes it on demand. So each file you want to access is only accessed when you want it. So everything is about vaporware right now, but the current approach. The approach we have is build a package with the default setting to build a binary package. That's also a main issue. We have the default settings that personally I never use binary packages because at the end it's never the settings I want. So maybe some people do. Maybe for desktop I guess it makes more sense. But we always want to change something. So what could we do? Create a binary package for every single combination? Maybe build a binary package, a very minimal one, and make deltas for each different combination. Then on top of that, I don't know, I'm open for suggestion as well. If we want to gather all those combinations, we have to do something with it. So that's what it is, the Gentoo at home. They had a system to start with a minimal VM, lots of scripts to automate, schedule to the community via BOINC, and update the base via CERN VMFS, and a lot of infra work on the back end. Well, there's some work already on the Gentoo side. I looked at a little bit. So what we could do to test the packages, instead of sending filing bugs for automation, we could maybe make a mirror tree. So for each single package, make a little script that will actually test the package on an automated manner. Maybe a or maybe we could do it a post-install state in each different ebuild, but I'm not so sure it's a good idea. There's some scripts already existing. They always change name. And obviously lots of infra work for the scheduler, for BOINC on the server side, the binary package storage, and to mix all the database of the tests. So the workflow, personally I don't like filing bugs for automation. I think it's very boring, and I'm not really sure why people really like architecture testing. You know, I don't think it's really, there's other things to do in life, I guess, than architecture testing, but it is something that really should be automated. So if we could cut some things in the workflow, I think we could work a lot better. We could, you know, resolve bugs before we send things to the users. So now what? Well, as I said, there's a lot of vaporware. I sent an ID for Google Sum of Code 2012 to start see if there is an interest. I had no candidates. I had 2 Gentoo users maybe interested in it, that sent me an email. If you're interested, I'll be, or if you want to work on that, on a similar project, let me know. That's it. Questions?
Any questions?
Is something working now with this from this stage, or it's
only working on the clusters I mentioned, nothing for the users yet. Yeah. So it was a call for the community here, really.
Is this not a more network throughput dependent project than like Einstein at home and all BOINC things that?
Sorry?
Well, Gentoo and compiling, it's more, in my opinion, it takes more bandwidth, and it requires a faster connection than the Einstein at home things, because I download a small file and then I do days of computations on it. But in Gentoo, with a fast machine, I need 100 meg lines to the internet just to keep the packages flowing.
It doesn't, well, compared to what we use well, in the things in science, no, it really doesn't take much network bandwidth there. Actually, you can recycle the virtual machine. You know, you only boot it once, and then you keep it around. It's not. No, it doesn't. No, I don't think the network would be a problem for the users at this stage.
Okay.
I read something here about the cvnts.
Yes.
I don't know, how this is working, your system, how this is working? You are testing, let's say, many combinations parallelly, or you are testing?
cvnts is just to build the base system. So I build it on a server, which amount, it's a user-based system. So I build it on a server, and each client mounts the cvnts there. So basically the base system is on prefix on cvnts, and each client uses the prefix network mounted.
Yeah. And have you, let's say, consider something for your futures like ZFS or BTRFS to use the features on copy on write for the clients and test the infrastructure every single every single combination with its own snapshot, let's say, and this can, let's say, make things faster. Or I don't know if you consider some features like this.
No, not yet, no.
Any other questions? Okay, thank you, Sebastien.
Yeah.